Good morning, everyone. We are going to be talking about special right triangles today. And our essential question, how are the side lengths related in special right triangles? The learning goal, I can use special right triangle relationships to solve, for missing side lengths. So we're really looking at the relationships between sides and finding side lengths in our triangles. So here goes. Sorry, just adjusting a few things on my end. Should have had that ready before we started. Whoopsie. There we go. All better. Okay, so the essential question and the learning goal will follow us on each slide as we go through. And let's continue on to the first one. All right, so starting off, the first thing we're actually going to talk about is something called Pythagorean triples. These are positive integers that represent the side lengths of a right triangle that satisfy Pythagorean theorem, a squared plus b squared equals c squared. Basically, someone sat down and figured out these work out to whole numbers, and so they're super handy if we just happen to know a few. So the first one we're going to look at is 3, 4, 5. What that means is on a triangle like the one that's given here, if A is 3 and B is 4, without actually sitting and doing Pythagorean theorem, I can know, because this 3, 4, 5 is a Pythagorean triple, that the hypotenuse must be 5, just by knowing that pattern 3, 4, 5. So one thing to be careful of and to make sure of, when you see these Pythagorean triples, remember the hypotenuse is always the largest side. So it would have to be the 5. So for quick side example is if I did something like this, for example, if I said 3 and 4, the A could not be 5 because that wouldn't make sense since the largest side has to be the hypotenuse. But as long as your largest side is the hypotenuse, then these numbers will always work. Okay, so then there's another way you can use 3, 4, 5 is actually by applying a scale factor. So if I multiply everything by 2, I could also say, hey, guess what? 3, 4, 5 will work, or 6, 8, 10 will also work in Pythagorean theorem. So that would basically be like A is 6, B is 8, and C is 10. And you can keep going. You could choose any numbers you want. I could multiply them all by 5. 3 times 5 is 15. 4 times 5 is 20. And 5 times 5 is 25. So I could have a triangle that's 15, 20, 25. So when you start to see those patterns, it can be helpful. So you don't actually have to do Pythagorean theorem. You can just say, oh, the missing one has to be this number because it follows this pattern. And then the next one, most common pattern is 5, 12, 13. Remember, these represent sides of a right triangle. And you can do the same thing where you multiply by a scale factor as well for that triangle. If you know those two sets of Pythagorean triples, that accounts for probably 90% of the right triangles you see in geometry. So super helpful if you just happen to know specifically the 3, 4, 5. But 5, 12, 13 also helpful. Two others that we're going to mention are 8, 15, 17, and then also 7, 24, 25. So these, again, are ones that you'll see pop up for side lengths for right triangles. I was going to say something else, but I forgot what it was. Oh, if you Google Pythagorean triples, they'll give you a whole bunch more because there's lots. But again, the most common one is the 3, 4, 5. All right. Then the first triangle we're going to look at today is the 45, 45, 90. I like to call it the Zach and Cody triangle because of the sweet life of Zach and Cody, the twins. So the main thing here, if you're not familiar with the sweet life of Zach and Cody, is basically that we have twins. Okay. And so with our twinsies, I could ask if, I'm going to use this, sorry, let me rewrite that. There we go. All right. So in our triangle, this is a 45, 45, 90. Those angles have to match because we are told that we have congruent sides. So those angles must be congruent as well. So 45, 45, 90, we have matchy-matchy sides, which means if I call this side Zach and this side Cody, if Zach is 5, then Cody is 5. If Zach is 10, then Cody is 10. If Cody is 3, then Zach is 3 because they're twinsies. They have to match. They have to be the same age. You think about it in terms of age, that's usually pretty helpful. So if I call Zach X, then Cody would also be X. And then, so that's pretty straightforward, but then we have the hypotenuse. So there's a relationship between the sides and the hypotenuse, and that is, this side I call the sweet life, from Sweet Life of Zach and Cody. And basically it says, you take however old Zach and Cody are, so whatever they are, we're going to put it here, and then we're going to tag on the square root of 2. So there's 2 of them, and they live in the same suite. So the 2 goes inside the square root, and you tag it on the end. That tagging it, as I'm calling it, is multiplication. So it's x times the square root of 2. So the math would be take however much Zach is, and we would multiply by the square root of 2. If I go in reverse, or this works for Cody as well, I could take Cody and multiply by the square root of 2. If I happen to know the hypotenuse or the sweet life, I can go in reverse and take whatever the value is for the hypotenuse, and I can divide it by the square root of 2 to find out one of the sides. And again, this is special right triangle. It only works on a 45, 45, 90. All right, so then we have a few problems to practice. And so I'm going to have us practice, but I'm going to give me just 1 second. All right, all squared away. Sorry, thanks for the quick second. All right, so this we're going to practice. So I'm going to give us a piece of information, and then we're going to find the remaining things really quickly. This screen, I will tell you, is not part of your official notes. It's not in your Google Doc. It's just for us to look at it and practice and kind of see how it works. So all of these triangles would be 45, 45, 90s. I'm just going to throw in a quick label of the angles just so that we're sure these are 45, 45, 90s. Great. All right, so this first one, I'm going to start with Cody. If Cody is 3, then we know Zach must also be 3. And then the hypotenuse, or the sweet life, would be however old Zach and Cody are. And then we tag on the square root of 2, because again, 2, because they're twinsies. There's 2 of them in the same suite. All right, next one. This time I'm going to give us Zach. So if Zach is 11, then Cody would also be 11. And then the sweet life is basically take their age and tag on the square root of 2. So 11 square root of 2 for the hypotenuse. All right, the lasty one here in this row. On this one, if I tell us the sweet life is 6 square root of 2, we can say, oh, well, I know that the 6 would be how old Zach and Cody are. Because remember, the sweet life takes the age of Zach and Cody, and then you tag on the square root of 2. So I can kind of work it backwards. All right, the last one I want to show you, this one's a little bit tricky, is sometimes we might have a weird number for our age for Zach and Cody. So specifically, this one I'm going to give us 7 root 3. So this is representing my Zach, which means Cody also has to be the same. So that one should be pretty easy just to match it. You don't have to think really hard. We just match it. We do have to be careful to know that this was in fact Zach, because it's one of the twinsy sides, not the hypotenuse. All right, so to get to the hypotenuse, we always start with either Zach or Cody. We put that value, and then we tag on the square root of 2. Remember that tag on is multiply. Then we have a rule for multiplying square roots. As long as both numbers are both in the square root, we can multiply them. Or if they're both outside of a square root, we can multiply them. We cannot mix and match. So I can't do 7 times 3 or 7 times 2, but I can do the 3 times the 2 and get 6. So the answer for the hypotenuse here would be 7 root 6. All right, so that kind of gives a little bit of practice on doing 45, 45, 90s. So back to our notes. Remember that this screen is not specifically notes. It was just a little bit of practice. So back to our notes. This is in your notes. We have a 30, 60, 90 triangle. And this one I call the 3 bears, based off of Goldilocks and the 3 bears. You may recall the story if you ever heard it when you were a kid. If you didn't, no stress. What you need to know is that the three bears is based off of Papa Bear, Mama Bear, and Baby Bear. And so I'm going to connect those to the sides of the triangle here in just a second. First, I need to label some angles. I have a 30, a 60, and a 90. Earlier in this unit, we talked about the shortest side of a triangle is always across from the smallest angle. So 30 would be the smallest angle. Across from that is going to be my shortest side. So the smallest side we're going to call Baby Bear. Baby Bear. Okay. Then the next largest angle would be the 60 degrees, or the medium-sized bear is Mama Bear. So across from the 60 would be Mama Bear. And then the largest side is across from the largest angle. So we would say the hypotenuse is Papa Bear. So if you don't like those labels, you can just call them by their mathematical names. Hypotenuse, short leg, long leg. Keeping in mind that the hypotenuse is the longest, Mama Bear or the long leg is the middle, and then Baby Bear or the short leg is the smallest. All right, so then this triangle has a different set of relationships between sides than the 45, 45, 90 we saw a minute ago. We don't have twinsies this time. We have different sizes. Everybody's different. All right, and in the story of the three bears, everything is all about how Baby Bear is perfect. Everything, his chair is just right, his porridge is just right. Everything is about Baby Bear. So we're going to start with Baby Bear, and we're going to call him X. Then Papa Bear, we know, is the largest bear in the family, and he happens to be twice as big as Baby Bear. So we call him 2X. 1 second. All right, sorry, another quick second there. All right, so Papa Bear is twice as big as Baby Bear. The math that we do is we take X and we multiply it by 2. So whatever Baby Bear is, we're going to multiply it by 2 to figure out what the hypotenuse is. So if Baby Bear is 8, then Papa Bear is 16, twice as big. And we can do it in reverse. If I tell you Papa Bear is 100, then Baby Bear would be 50. We just divide by 2 if we go backwards. So that's the math. All right, then we also have Mama Bear. So Mama Bear is not twice as big as Baby Bear because she's in the middle. She's not as big as Papa Bear, but she's bigger than Baby Bear. So Mama Bear loves Baby Bear. Her whole world is all about Baby Bear. So we're going to copy whatever Baby Bear is, and then we're going to tag on the square root of 3, which is Mama Bear loves Baby Bear, but she takes care of all 3 bears. Okay, so we have a 3 for the 3 different bears, and in the square root or in the house. Takes care of all 3 bears in the house. And that's the relationship. So mathematically, to go from Baby Bear to Mama Bear, we're going to multiply by the square root of 3. If we go in reverse, if we start at Mama Bear and work our way backwards, we're going to divide by the square root of 3. All right, so let's give it a couple of practice questions here. And again, all of these we are assuming are 30, 60, 90 triangles. I'm going to really quickly throw in 30 degrees just to clarify that these are all 30, 60, 90 triangles. Okay, so here we go. The first one we're going to try is pretty straightforward. I'm going to give us Baby Bear. And so we know, once again, Papa Bear is twice as big. So Papa Bear is the hypotenuse. It must be twice as big. And then Mama Bear loves Baby Bear, and she takes care of all 3 bears in the house. So we put Baby Bear and tag on the square root of 3. All right, again, trying that out. This time I'm going to start with Baby Bear is 4, and I'm going to go straight to Mama Bear. So from Baby Bear to Mama Bear, we're going to multiply by the square root of 3, or we write Baby Bear and we tag on the square root of 3. And that gives us the value for Mama Bear. Then Papa Bear, the hypotenuse is twice as big as Baby Bear, so 4 times 2 is 8. On the next one, we're going to start with the hypotenuse, this time Papa Bear. So if Papa Bear is twice as big as Baby Bear, if he's 20, then Baby Bear has to be 10, or divide by 2, because remember, Baby Bear is smaller. And then to get to Mama Bear, we write down Baby Bear and tag on the square root of 3, excuse me. All right, then this last one, we're going to start with this one, which is mama bear. So if I start with mama bear, remember mama bear tells you baby bear's age by looking, if you just look in front of the square root of 3. I almost said cube root in my head. Square root of 3. So baby bear would actually be 7. It's just that number in front. Okay. And then if baby bear is 7, papa bear is twice as big. He's 14. All right, these last two at the bottom are going to be a little bit trickier because we're going to make some funky values here. So starting on this first one, I'm going to give us baby bear, and I'm going to say baby bear is 6 root 2. So that's like a weird number for baby bear, but it's okay. We're going to follow the math. We know papa bear has to be twice as big, or multiply by 2. Twice as big. I'm multiplying it by 2. Now, because 2 is not in a square root and 6 is not in a square root, I can multiply those together. 2 times 6 is 12, but the square root of 2 doesn't get to multiply by anyone because it's the only one in the square root. So papa bear, twice as big, is going to be 12 root 2. Then when we go to mama bear, normally we would just write baby bear, and then we would tag on the square root of 3. Remember, tagging on, we're multiplying. Since the 2 and the 3 are both in the square root, we can actually put those together. 2 times 3 is 6. So mama bear is actually 6 root 6. All right, this last one, nice little challenge problem for you. If papa bear is 8 root 3, can we find the rest of the sides of the triangle? So notice every single time we keep going back to, either we start with baby bear or we immediately go back to baby bear. So if I start with 8 root 3, papa bear is twice as big as baby bear. What does baby bear have to be? If you're not sure, remember the path is to take that value for papa bear and divide it by 2. So the square root of 3 is pretty much just going to sit there because it's in a square root, but my 8 and 2 I can divide, so I get 4 root 3. Then when I go over to mama bear, again, I have this weirdness where baby bear is 4 root 3, but to get to mama bear, I have to tag on the square root of 3. When I do this math, I can multiply 3 times 3 because they're both in the square root. I get square root of 9. This happens to be a square root that we know. Remember, square root means what number times itself. So what number times itself is 9? The answer is 3. So that square root of 9 actually equals 3. Then I can really quickly multiply 4 times 3 and I get 12. So in this case, this triangle is a little weird. We get mama bear is 12. Now remember, the problems at the bottom here, these are the more challenging ones. The ones at the top are going to be a little bit more straightforward. Most of the problems in your worksheet are like the top row, both for the 45, 45, 90 and the 30, 60, 90. All right, and that finishes, remember this, I don't know if I stated that clearly, I apologize. This screen that we're looking at right now is not officially part of your notes. It was just for us to kind of practice and see how it works. So the official notes were just that page where it said 45, 45, 90, 30, 60, 90, those two different triangles. And I think that's pretty much it. Definitely check out the worked out solutions, which are also going to be attached to the assignment. If you have questions, let me know. Have a great day, everyone. We'll see you later.